Hello everyone, welcome to Calculus BC. We're starting lesson number 39, where we're talking about calculus of polar curves. In this lesson, we're going to talk about derivatives and integrations of polar functions, and today we're going to start with the slope of the tangent line, which you guys know very well as a derivative. So remember that the derivative is the change in y with respect of x, but we're given functions for polars where y is equal to r sine of theta and x is equal to r cosine of theta. So couple things you can do here to find these derivatives is memorize this formula or do the method that I think is a little bit easier and what I'm going to show you guys today in the video. So the question says find the slope of the tangent line to the graph at a given point, and it's given us the function r equals 1 minus 2 cosine of theta. Before I do the problem, one thing I do want to make notice here is what's right here. This is actually the easiest way for me to show you guys to do this, is we wanted to find the derivative of y with respect to theta, and then we're going to find the derivative of x with respect to theta. So what we ultimately want to do is make ourselves a y value over here, and then also ourselves an x value, and this will make sense to you guys here in a second. So we know that y, and this is from the previous lesson, we know that y is equal to r sine of theta, and we know that x is equal to r cosine of theta. So if I were to multiply both the left and the right hand side here by sine of theta, so I'm going to take r equals 1 minus 2 cosine of theta, and I'm going to multiply the left hand side and the right hand side by sine of theta. So I'm going to do sine of theta here, and I'm going to do sine of theta here. Well, then I'm going to be left on the left hand side with r sine theta, and then I'm going to go ahead and distribute the sine of theta here. So I'm going to get sine theta minus 2 sine theta cosine theta. And so what's actually helpful here, guys, is the fact that r sine of theta is actually equal to y. So now I have a function that y is equal to sine of theta minus 2 sine theta cosine theta. And so what I'm going to end up doing here is just rewriting this. Well, sine of theta is good, but 2 sine theta cosine theta actually just becomes sine of 2 theta. So all I can now do, guys, and this is kind of like very similar to implicit differentiation, is I can take the derivative of this now implicitly. If I take the derivative with respect to theta, right, I want it with respect to theta. So I'm trying to find right now dy d theta. So this is the first part that we're going to do. Well, if I take the derivative of y, dy d theta, I can now get the derivative of this. Well, this would be sine of theta would be cosine of theta, and then minus the derivative of sine of 2 theta would be cosine of 2 theta times 2. And so all I really want, guys, is the value of this. Well, I already know what theta is here, so I can go ahead and plug in for my function as cosine of 2 pi over 3 minus 2 cosine of, and again, I can do 2 times 2 pi, which would be 4 pi over 3. So I can find these values as, well, the cosine of pi over 3 is 1/2. Well, in this particular quadrant, this is quadrant 2, I know that this is going to be negative 1/2. I'm going to do some minus 2. Cosine of 4 pi over 3, this is in quadrant number 3, excuse me. So again, it's negative 1/2. So I get negative 1/2. This is going to be plus 1. So I get 1/2. So this first part, dy over d theta, is going to be equal to 1/2. So if I'm trying to find dx over dy over dx, I can simply first of all find dy over d theta, which we found is 1/2, and now we got to do this process one more time with dx over d theta. So let's do that next. And I had no room here, so I'm going to write it over here. So we're going to not do this one in this video. So now I'm going to do the same thing. I want to go ahead, and I'm just going to go ahead and just multiply both left and right by now cosine of theta, right? Because remember that x is equal to r cosine of theta. So if I multiply the left-hand side by cosine theta, and I multiply the right-hand side by cosine of theta, then I haven't changed my function at all. And so this now becomes x, and I'm going to go ahead and distribute this. I'm going to get cosine of theta minus 2 cosine squared theta. And so we can do the same thing that we did over here. We can take the derivative of both of these implicitly. So the derivative of x would be dx, but with respect to theta. I can take the derivative of cosine, which would be negative sine of theta. And then remember, we are going to use the chain rule here. So we're going to take 2 times cosine squared theta. Well, we're going to move the 2 down. We're going to leave everything inside of the parentheses. And then we're going to multiply by the derivative of cosine. And here, guys, we could simplify it here, or we can just plug in. We don't actually necessarily have to simplify. So we can go ahead and just plug in now 2 pi over 3. So I get negative sine of 2 pi over 3. And then the negative and the negative here becomes a plus. I get 4 times the cosine of 2 pi over 3 times the sine of 2 pi over 3. So sine of pi over 3 is the square root of 3 over 2. This is in quadrant number 2 where sine is positive, but we still have a negative here, so we're going to go ahead and do a negative sign right there. We're going to do 4 cosine of square root of 2 pi over 3 is 1/2, but again, we're in quadrant number 2, so we're going to do negative 1/2. Sine of 2 pi over 3, we've already discussed that. It's going to be the square root of 3 over 2. And we're going to start simplifying this, so we're going to get negative square root of 3 over 2. This and this cancels, right? The 2's and 4 cancel, so I'm left with negative square root of 3. And we're going to get, this is negative 3 square root of 3 all over 2. So what we want to do now is find what dy dx is. So that's going to be dy over d theta, that value that we found right here, all over dx d theta. And so we're going to get 1/2 over negative 3 square root of 3 over 2. And so when we simplify this, we get negative 1 over 3 square roots of 3. So this is a lot of work. It is a lot of work for one problem. So this is how you find this particular example. So if we come down here to example number 3, most of the time they're not going to ask you to find both of them. They may ask you to find the point of maybe the horizontal tangent to the curve or the vertical tangent of the curve. So they may just ask you for one or the other. And so when we do this problem, just remember that we always look back at dy dx in terms of polar is dy d theta all over dx d theta. So this becomes the numerator and this becomes the denominator of our derivative. So you guys know that when I'm looking at a derivative and I said the derivative equals 0, that means my numerator has to be equal to 0. So this is where I would have to find the horizontal tangents. So I would just have to do the dy d theta. And if I'm asking for the vertical tangents, then I'd have to just do dx d theta. So let's just say this curve is asking us for the horizontal tangent. So just that. Well, if we're going to do just that problem, then we just want to do dy d theta. So we know that we're going to take our function here and we're going to multiply both sides by sine. Because, and you guys know that if we do that, then this r sine theta simply becomes our y. And then we simplify our right-hand side by distributing. So we get sine of theta plus sine squared theta. And, students ask, could you use the product rule over here? Yes, you can. You can absolutely do that. I think it's just easier to just go ahead and simplify. That way you just have two terms. And then when we do the problem, we're going to do dy d theta. And then the derivative of sine is going to be cosine of theta. Again, we can use the chain rule here. The derivative of sine squared theta is going to be 2 sine theta times cosine theta. And we're going to set this equal to 0. We're going to set this equal to 0. One thing I could also say about these problems is that technically, if we were implicitly differentiating, we would have, dy over d theta here. And then we take the derivative of sine of theta, it would then be d theta over d theta, all right, which would just be 1. So that's why I don't do anything on the other side here. So here's our derivative. We've set it equal to 0. And so we got to figure out what intervals. And usually, they would give us like 0 to 2 pi. So let's just assume that we're looking to find where this polar graph has horizontal tangents on the interval from 0 to 2 pi. Well, this, now we're going to take out the cosine of theta. And we'll be left with 1 plus 2 sine theta is equal to 0. So we want to know where cosine of theta is equal to 0. And then where 1 plus sine 1 plus 2 sine theta is also equal to 0, which again, you guys would get that sine of theta is be equal to negative 1/2. So cosine of theta is on pi over 2, so let's change the color up so we can pop here. So pi over 2 and 3 pi over 2. And then over here, sine would be negative 1/2. Well, this is the pi over 6 family. And sine is negative in quadrant number 3 and in quadrant number 4. Now, the last thing we have to do for this problem, again, we're just looking at the horizontal one in this video, is we have to graph this function. We have to kind of see an idea of what's going on. So we talked about graphing in the other lesson. So you guys can see that this is a 1 and this is a 1. So you guys know this is a cardioid. You know that since it's sine, it's going to be symmetric to the y-axis. The 1 plus 1 gives you a 2. So we know of it 1, 2. We're going to put a point. We also know that the a, right here, the 1, is going to be here and here. And then we know, because it's a cardioid, that it's going to end up looking very similar to, so let's graph the function now, look something similar to this. Right, something like this. So I want you guys to see the reason that we drew this is that the solution actually has only 3 answers. So we have one here, we have one here, and we have one here. So you guys can see that we actually have 4 possible solutions. Well, this is where it's really important that you guys know what the functions are. So we know that the graph starts right here, because if I plug in 0 for theta, then I know that my radius is going to be 1. And so then I know that the very first one I come to, very first one, so we look at our numbers here, so we can actually put them in order. So we know the first one's going to be pi over 2, because that's the first order that's the first one we do in our unit circle. And then we can come over to this one right here. Well, the next one in the unit circle is going to be 7 pi over 6. And then what happens is right here, that's actually 3 pi over 2. This is actually 3 pi over 2. If you plug in 3 pi over 2 to our function, we're actually going to get 0, right? The sine of 3 pi over 2 is negative 1, so we get back to the pole. So you guys can see that this is a sharp corner. It's not differentiable, so this is not a solution to this problem. And then you come back to this one, and you can see that this ends up being 11 pi over 6. So for this particular example, our answers are going to be pi over 2, 7 pi over 6, and 11 pi over 6. I'm going to do the next video, guys, and I'm going to do the vertical tangent, and I'll do the example number 2 at the very top of the page. So I'll do what I didn't do on this page, I'll do it in the second video. So I hope that that makes sense to you guys, and we're going to come back and do some more, but it requires a lot of thinking, right? These videos require, or these problems require a lot of thinking on what's going on. So I hope this makes sense to you guys, and I'll see you in the next video.